Hello again and welcome to the next video of section 6, the UI health bar. In the previous video we've learned about kill zones. In this video we'll discuss about the UI health bar. In the previous section we introduced the first danger and hazard to the game, namely a kill zone that can damage and potentially kill the player. As a result, their health has the potential to reduce from its starting state. It's therefore useful both to us as developers and gamers to visualize the health status. For this reason, let's focus on rendering player health to the screen as a UI health bar. This configuration of objects will also be made as a prefab, allowing reuse across multiple scenes. This will prove a highly useful feature. To get started, create a new GUI canvas in the scene, any scene, by choosing Game Object, UI, Canvas from the application menu. Selecting this will automatically create an event system object in the scene, if one does not exist already. This object is essential for proper use of the UI system. If you accidentally delete it, Event System can be recreated by choosing Game Object, UI, Event System from the application menu. The newly created canvas object represents the surface on which the GUI will be drawn. Next, we'll create a new and separate camera object for the UI, adding it as a child of the newly created canvas. By creating a separate camera for UI rendering, we can apply camera effects and any other image adjustments separately to the UI if we need to. To create a camera as a child, right-click on the canvas object in the hierarchy panel, and from the context menu, choose Camera. This adds a new camera object to the scene as a child of the selected object. Now configure the UI camera to be an orthographic camera. This displays the camera settings for an orthographic camera. Remember that an orthographic camera is truly 2D insofar as it removes perspective and foreshortening effects from the render result, which is appropriate for GUIs and other objects that live and work in screen space. In addition, the camera depth field from the Object Inspector should be higher than the main game camera to ensure that it renders on top of everything else. Otherwise, the GUI could potentially render beneath and be ineffectual in the game. The created camera is almost ready to go. However, right now it's configured to render anything in the scene just like any other camera. This means that the scene is effectively being rendered twice by two separate cameras. This is not only wasteful and poor for performance, but it makes the second camera totally unnecessary. Instead, we want the first and original camera to show everything in the scene in terms of characters and environments, but to ignore GUI objects, and likewise the newly created GUI camera should show only GUI objects. To fix this, select the main game camera and from the Object Inspector click on the Culling Mask drop-down list in the camera component. From here, remove the checkmark for the UI layer. This drop-down list allows you to select layers to be ignored for the rendering from the selected camera. Now select the GUI camera object and for the culling mask filled in the camera component, select the Nothing option to deselect all options and then enable the UI layer to render only UI layer objects. By default, any newly created canvas is configured to work in the screen space overlay mode, which means it renders on top of everything else in the scene that is not associated with any specific camera. In addition, all GUI elements will be resized and scaled on the basis of this. Consequently, to make our work simpler, let's start creating the GUI by first configuring the canvas object to work with the newly created GUI camera. To do this, select the canvas object and from the canvas component in the Object Inspector, change the render mode from screen space-overlay to screen space-camera. Then drag and drop the GUI camera object to the camera field. Next, let's configure the canvas scaler component, which is attached to the canvas object. This component is responsible for how the GUI appears when screen size is changed, from either upscaling or downscaling. In short, for our game, the GUI should up and downscale relatively to the screen size. For this reason, change the UI Scale mode drop-down to Scale with Screen Size, and then enter the game resolution of 1024 by 600 in the Reference Resolution field. Now we can start adding GUI elements to the game, knowing that they will display correctly when added to the scene. To display health, a representation of the player will be useful. Create a new image object by right-clicking on the canvas object from the hierarchy panel and choosing UI Image from the context menu. Once created, select the image object and, from the Object Inspector in the image component, drag and drop the player head sprite from the project panel to the source image field. Then use the Rect Transform tool, T on the keyboard, to resize the image in place at the top left corner of the screen. If you cannot see the added head image, remember to assign the UI layer to render by the UI camera. In addition, you may need to offset the GUI camera back along the Z-axis to include the head sprite within the camera frustum viewing area. Finally, anchor the head sprite to the top left of the screen by clicking on the Anchor Preset button in the Rect Transform component from the Object Inspector. Choose top left alignment. This locks the head sprite to the screen top left, ensuring that the interface would look consistent at multiple resolutions. To create the health bar, add a new image object to the GUI canvas by right-clicking on the canvas and selecting UI, Image from the context menu. For this object, leave the source image field empty and choose red for the color field, RGB 25500. This will represent the background or red status for the health bar when it's fully depleted. Then, use the Rect Transform tool to resize the bar as needed, anchoring to the top left screen corner. To complete the health bar, we'll need to use scripting. Specifically, we're going to overlap two identical health bars on top of each other, one red and one green. We'll scale the green bar as the health reduces so that it reveals the red bar underneath. Before scripting this behavior, further configuration is necessary. Specifically, let's change the pivot of the health bar away from the center and to the middle left point, the point from which the health bar should scale as it reduces and increases. To do this, select the health bar object and from the Object Inspector, enter a new pivot value of 0 for X and 0.5 for Y. To create the green overlay for the health, select the red health bar and duplicate it. Name the duplicate health_green and drag and drop it to appear beneath the red version in the hierarchy panel. The ordering of objects in the hierarchy relates to the draw order for GUI elements. Lower order objects are rendered on top of higher order objects. Now we'll need to make a new script file linking the width of the green bar to the health of the player. This means that reduction in health will reduce the width of the green bar, revealing the red bar beneath. Create a new script file named healthbar.cs and attach it to the green bar. Now we'll see the healthbar.cs code. The health bar class is responsible for reducing the width of the green on the top health bar based on the player health. The size delta property of the Rect Transform is used to set the width of Rect Transform. The mathf move towards function is used to gradually and smoothly transition the health bar width from its existing width to its destination width over time. That is, as and when the player health is reduced, the health bar will gradually decrease, as opposed to instantly. More information can be found at the online Unity documentation at this site. Finally, make a prefab of the UI objects by dragging and dropping the topmost canvas object from the hierarchy panel to the project panel in the prefab folder. This allows the UI system to be reused across multiple screens. Congratulations! In this section we've created a complete terrain for a single scene using Edge Collider components. This terrain not only fits the screen and appears as intended, but acts as a physical obstacle for the player character and other physics-based objects. Of course, so far we've been using a rough approximation for the player, and now it's time to expand upon this. In the next video, we'll learn ammo and hazards.